So it's 4 o'clock. Let's get started. Welcome. Thanks for coming to this talk on iOS development. First steps in iOS development, really. Before we get started, I'd like to get a quick review, background of where you're coming from. So how many of you are .NET developers or architects? Okay. And are you familiar with frameworks like WinForms, WPF, XAML, Silverlight, any of the above? Yeah, okay, that's good. Any other backgrounds, like maybe MFC, C++, Qt, stuff like that? Okay, that's cool. So I think you'll find that iOS is a bit different, but then I have a slide at the end of the presentation that says it's basically just another framework, just another language, just another development environment, and I hope you'll find that it really is. And many people I talk to kind of find it hard to get started. And so I hope that this talk will give you the general background, the tools, the language, so you can start working on your own iOS applications, so you can start appreciating what it really means to develop iOS applications. I'm Sasha Goldshtein. I'm the CTO of an Israeli company called Sela Group. And I'm also a Microsoft C# MVP, which doesn't really play along with iOS and Objective-C development. But I've actually been doing some interesting integration of the two. For instance, I have iOS applications that talk to Windows Azure mobile services and all different kinds of interactions like that. And I think that's maybe one of the reasons why many people at this Microsoft-focused conference are interested in mobile technology and cross-platform frameworks. And I hope this is also why you are here today. Even if you're just here because you're curious, that's also perfectly fine, of course. So let's get started by describing the iOS platform. And I'm going to talk a little bit about the platform philosophy, what kind of devices and versions of iOS we have today. And then we'll just dive into the language, into the development environment, and build a couple of simple applications. So the iOS platform could really be viewed as 4 different layers. You have Darwin, the operating system kernel, at the bottom, which is shared with OS X, OS X, which is what you run on Macs, which is what I run on my Mac. It's really pretty much the same kernel, so things like driver development would look quite similar, although, of course, the firmware is completely different, the hardware is completely different. But it is a Unix-inspired kernel. And so the operating system exposes things like system calls, like a shell, user IDs, group IDs, but you are shielded from that kind of details by a set of additional layers. And the first one is so-called core services. And these are relatively low-level APIs for accessing things like location, for creating threads and doing asynchronous programming in general, for network access, even for low-level graphics like OpenGL or even 2D simple graphics. That's the kind of things you'll find in this layer. And it's mostly C-oriented, so it's just a bunch of global functions, no namespaces, nothing of that sort, just a bunch of C APIs. On top of those, you'll find Cocoa Touch. And that's, you could say it's the UI framework, but it's really more than that. This is a set of objects. This is a set of classes written in Objective-C, and you interact with those from Objective-C. And they implement UI controls, they implement gestures, navigation, views, and view controllers that we're going to talk about. This is where you find things like buttons and edit boxes, and this is where you find transitions and animations. So all the kind of things that have to do with really the face of your iOS application, you'll find in Cocoa Touch. And then on top of those 2 layers, which you often have to integrate with, you'll find your apps. And currently, the App Store has 877,013 apps. I'm sure this number has changed since I've written the slides. And no one really knows the true number. I mean, maybe except the App Store itself, the App Store maintainers. There's also a couple of 100,000 inactive apps, which you can't download from the App Store anymore, but they're still installed on a bunch of devices around the world. So this puts the total number just above 1 million applications written on top of Cocoa Touch and core services. This is probably billions of lines of code in Objective-C mostly. And so the first thing we're going to do really, once we get through the introduction, is look at Objective-C, the language. In terms of the platform philosophy, I see 3 different perspectives here. So one is the user perspective. And from Apple's viewpoint, the user should feel at home on any iOS device they own. And even on Mac devices, if they already own an iPhone, they should feel at home. If they own a Mac, they should feel at home on an iPad, and so on. And this is achieved by seamless services that users get, like synchronization of their own applications across devices, like backup, like a single unified iCloud/iTunes/App Store account that they use for all their purchases, for all their interactions with Apple. The fact that you can only get applications from a centralized store, which is maintained by Apple, that's all part of the user experience that Apple is trying to enforce. From the developer's perspective, Objective-C, which is the language you use for most iOS applications, is strongly object-oriented. Its roots are in Smalltalk, which was a strongly object-oriented language where you pass messages to objects, and objects communicate by replying to messages, responding to messages. So it's very object-oriented. There's just one official language which is documented and supported by Apple, and that's Objective-C. Even though you can develop iOS applications using JavaScript, like maybe through frameworks such as PhoneGap, you can develop iOS applications in C# using Xamarin's iOS framework. You can even develop iOS apps in Ruby using Ruby Motion. But again, Apple only supports Objective-C, and the iOS documentation is all tailored for Objective-C. And from the architecture perspective, iOS enforces separation of concerns through the MVC pattern, Model View Controller. And MVC is called a kind of old dish. I mean, people are talking today about MVVM and MVP and all kinds of different frameworks and patterns like that. But iOS really uses the classic MVC from the 70s. And you'll find that it's kind of easy to get used to, although there are some things from WPF and other XAML-based frameworks which you will find that missing, like binding and dependency properties and stuff like that. And finally, from Apple's standpoint, Apple wants and enforces full control of the ecosystem, which is probably one of the biggest points critics make at Apple. They control the hardware completely, the entire supply chain, from manufacturing to actually obtaining the source materials, and finally to assembling the devices somewhere in China or Brazil. And they control the software. They control the operating system, and through the App Store, they also control every additional piece of software that you can install on iOS devices. It's true that you can jailbreak your iPhones and your iPads, and Apple doesn't actively fight this because people find security vulnerabilities and find a way to jailbreak the devices and install arbitrary third-party applications. But again, most users don't do that. I mean, the number of devices, the share of devices that are jailbroken is in the single number, maybe 5 or 6 or 7% of devices. So that's the philosophy. In terms of versions and devices, it's really not a very fragmented system. I have a similar talk on Android, and then I have hundreds of devices I could put on the screen, hundreds of versions, hundreds of different resolutions, orientations, combinations of hardware and software, sensors. But iOS only runs on about 3-4 devices and only is actively supported on about 3 or 4 devices. And those would be probably just a selection here, the iPhone 4 and 4S, which many people are still using today, the iPhone 5, which I have in my pocket, and the iPhone 5C and 5S, which were just released a couple of months ago. And the operating system versions running on these hardware devices are also not very fragmented. So you have iOS 7, which is Apple's newest operating system version, released together with the iPhone 5 and the iPhone 5C and 5S. You have iOS 6, which has a pretty decent market share. And prior to the release of iOS 7, iOS 6 already had a 95% market share. So there are many people developing applications today who completely ignore older iOS versions. And in a matter of a few months, you'll probably see a similar market share for iOS 7. And so in a few months, you could stop actively supporting iOS 6 versions of your application, and users will probably migrate to iOS 7 anyway. And if any of you own iPhones or iPads, you might not like the way iOS looks. You might not like the new animations, the new themes, the new look and feel in general. But users really do tend to follow this migration path pretty quickly. And in the first 48 hours since iOS 7 was released, it was already installed on 30% of all iOS devices. This is pretty crazy. I mean, you don't see that with Windows. You don't see that with Android. You don't see it anywhere else except in this very closed and controlled Apple ecosystem. Now, in terms of resolutions and form factors, again, there's very little fragmentation. You find that there's basically 3 resolutions that you really have to think about. The first is the iPad resolution, and also the higher end, the Retina iPad resolution, which is basically what I'm now using to display this presentation. That's 1024 by 768. And the fact it's double on the Retina iPads doesn't really change the layout of your application because it's just doubled display. So you only have to change your graphical assets. You need better resolution pictures. But the text that you're displaying, the layout of your controls, it really doesn't change at all. The other 2 resolutions that you actively have to think about and support is the iPhone 5 resolution, which is kind of weird. It has a taller shape than previously, so it's 640 by 1136. And finally, the iPhone 4 older resolution, 640 by 960, and its older twin, the iPhone 3GS, 320 by 480. So it's basically just 3 resolutions to support because you have the bigger iPad resolution, you have the smallest iPhones and Retina iPhones, and you have this slightly taller iPhone 5. Just 3 resolutions to support is, again, it's crazy. I mean, you don't have that on Windows, you don't have that on Android. It makes application development that much easier. And many applications only target iPad or only target iPhone. So again, it's much less work to get your application working and looking great on every platform. So again, like I said, don't worry about Retina displays. You basically only have to shape up your images, make them double the pixels. And in terms of the iPhone 5's greater height, you basically have a mechanism called auto layout, which will resize your view correctly if you're running on an iPhone 5. And we'll see, I think, an example of this just out of the box as we build our UI. So what are the different components we have to talk about when developing for iOS? The first part would be the language, Objective-C, which we're going to look at just in a couple of moments. The second part is the development environment, which is Xcode. And this is the only Apple-supported development environment for iOS today. And you can only install Xcode on a Mac. So in a way, there's also a 4th component here, which is a Mac. You really need a Mac to get started. By the way, if you don't have a Mac and you still want to experiment, there's a couple of services today that let you rent a Mac in the cloud. So you basically connect to a remote Mac server, and you can develop your applications there. And Xcode is free, by the way. Totally free to download from the Mac App Store, and older versions of Xcode are also available standalone. And the third part is the framework, the UI framework called UIKit, and other auxiliary frameworks like location and maps that I'm going to show you today. So these are really the 3 things that we have to focus on. And let's get started with Objective-C. Before I actually do that, have any of you written any Objective-C before? That's great. You're just the right audience, or you're too shy, but anyway, let's just take a look at Objective-C. It really is, when I first learned it, I was thinking, this is nothing like I've ever seen before. They've just come up with a language that looks completely different from C++, C#, VB, anything else you've probably encountered. So a class in Objective-C is pretty much mandatory. Pretty much every piece of code you write belongs in a class, much like object-oriented languages like Java and C#. And a class in Objective-C is split between a header file, an H file, and an implementation file, an M file. So this is pretty similar to C++. Only in C++ you have H files and CPP files, or CC files. Here you have M files. And you have a couple of keywords for specifying, well, this is the interface, this is the header of this class, and this is the implementation of that header. And these are the interface and implementation keywords. So here on the left, I have a myclass.h file, which has an interface to a class called myClass, and it derives from NSObject. NSObject is a base class that most classes you'd use in your iOS application will derive from. However, it's not mandatory. Unlike C# or VB, you don't have to have every class inherit from NSObject. However, it provides a bunch of useful services. And if you're going to put your class in a collection, like an array or a dictionary, you really have to have it derive from NSObject. So we'll just skip this for the rest of the talk and assume that every class we write is going to derive from NSObject. On the implementation side, we include the header file using the import directive, and then we specify that this is the implementation of the class. Between these two lines, we can put the actual implementation, the methods, the properties, the fields. So let's start with methods. And there's really a unique notation here for methods in Objective-C. So in the interface, I have here a class called cat, derived from NSObject. And it has three methods: meow, does like other cat, and age. Now, the methods return void, bool, and int, respectively, which sort of makes sense, except it's in parentheses. And the dash here, the minus sign, means it's an instance method, unlike static methods. A static method would have a plus here instead of a minus, right? Makes perfect sense. So these are three instance methods on the cat class. The first one's called meow, does not return anything. The second one returns bool, true or false, and accepts a pointer to another cat. So does this cat like the other cat? And finally, the third method here is much like a property, like an accessor. Age returns the age, returns an integer, which is the age of that cat. Now, in the implementation, let's take a look at the three methods here. So the meow methods, the meow method just prints something out to the console, and it's not particularly interesting. The age method returns 7, and does like other cat is a little bit more interesting. So it takes a cat, other, and then it wants to compare our cat's age with the age of the other cat that we're looking at. So this here, the square brackets here, are the way you invoke methods. Or in the iOS, in the Objective-C terminology, you don't invoke methods, you send messages. This is how you send a message to an object. So you use these brackets to send a message to an object. So here, I'm sending the age message to the other object. So I'm calling the age method on the other object. And that returns an integer. And I'm comparing that with the result of the age method, the age message, passed to my object, which is called self in Objective-C. So this is one area where the Smalltalk influence is really strong. And Smalltalk self is also the way you refer to this. And if my age is less than or equal to the other cat's age, I'm going to return yes, which is true. But they have yes and no for Booleans. Yeah. You could also write true. You can actually return 1 and 0, but yes and no are kind of what you use. Now, what about null? What if other is null? It's a pointer. Pointers point to memory. Pointers can be null. Well, Objective-C takes an interesting position on this. If you send a message to an object that is null, or nil, as they actually say, then that message works. It just isn't really invoked. It returns the default value for that type. So, for instance, if you send the age message to an object which is nil, it will return 0, because 0 is the default value for an integer. And if you send does like other cat to an object which is nil, you'd get false, because no, actually, is the default value for Booleans. So messages that you send to nil objects just return nil or a default value. And this actually helps. I mean, it's really counterintuitive for us, for most developers, I guess. But it really helps in this situation, for example. I mean, if the other cat is nil, there's no way I can like that cat. And so maybe this logic here would just flow through and have me returning no in that case. OK, so that's methods. And the age method here looks suspiciously like a property. And languages like C# and VB and Python, they have property accessors, all right? So Objective-C does as well. It didn't originally have properties, but Apple introduced properties pretty early in the game. And before we get to properties, let's take a look at fields, how you declare fields and your objects, actual state that you maintain. So in this situation here, I have an interface cat, which has a public instance field called age underscore. This is a public instance field because it's part of the interface. You can do the same trick exactly with the implementation. you could just copy that part with the curly braces, and then you'd have a private instance field. So that sort of makes sense. For now, we have this public instance field, age underscore, and then we want to pass in the cat's age when creating a cat object. So here's the constructor for a cat. It takes in an age, and it's supposed to initialize a cat with that age. Now, constructors in C#, VB, C++, pretty much every language you probably know, constructors do not return anything. Constructors are void, and you don't even have to write the word void. However, in Objective-C, constructors are not void. They return ID. ID is kind of a dynamic keyword, which means whatever the instance of the current class is, more or less, really. And so in our case, ID is just going to be cat pointer, a pointer to a cat. So init with age, the constructor, the initializer, returns the initialized object. So let's take a look at the implementation. Here's the implementation for init with age. Takes an age, it's supposed to return an ID, my cat, after initialization, and the first thing it does is call the superclass, the base class initializer, because our class derives from mammal, and maybe mammal derives from NS object. So we call the base class initializer here, and that returns us something that we assign to self. Again, doesn't make sense in most object-oriented languages to modify this, to modify self inside the method, but initializers are allowed and supposed to do that. So you call the superclass initializer and assign the result to self, and then you continue initializing the current object. If self, then I'm going to assign the public instance field to whatever age was passed in as a parameter. And finally, at the end of the initializer, you return self. So this is how an object is born. You allocate it and then initialize it. And we'll look at the allocation step in a moment, but so far, we only have seen the initialization part, where you have an object, you initialize it, and you return it back. So now we can use properties, because public instance fields are really frowned upon, even in Objective-C. So instead of having age be a public instance field, we now use the property keyword, the @ property keyword, to say that age is actually a property. And then you have this non-atomic specifier in here. And it's really kind of important, because for some obscure reason, by default, properties in Objective-C are thread safe. They are synchronized by default. So if you access a property from different threads, there's a lock that's taken on the current object. You rarely really intend to do this, because methods are not synchronized by default. It's just properties. So this is why almost every property declaration you'll ever see will use this non-atomic specifier, because the default is atomic. The default is that it is thread safe, and it will acquire a lock on the current object prior to actually getting into the property method. So this is a property of type int called age. And the initializer looks pretty similar in the declaration step, but then the initialization is slightly different. So here I'm calling superinit and assigning to self in the same line, and also checking whether the result was nil. If it wasn't nil, I want to set the property. Now I could say self.age, and this is how you typically invoke properties of other objects. But in our case, we have a shortcut, because as soon as you use this property keyword, the compiler auto-generates a field for you. And the field is called underscore whatever the name of the property was. So again, this is pretty similar to what you have in C# and VB with automatic properties, except you don't see the field explicitly. In Objective-C, the field is there, and you can access the field directly without going through the property at all. So we have a cat. It has a couple of methods, has a couple of properties. That's pretty much the basics of the language. But we have just one more step, which is allocating and actually using these objects. So here we're allocating and initializing a couple of cats, Felix and Shadow. Now you'll notice before calling the initializer, we need to create an object from somewhere. The initializer only modifies and returns an existing cat object. So every class that derives from NS object has a static alloc method provided by the system, provided by the framework. And so to allocate a cat object and then initialize it, you begin by calling the static method catAlloc, and then passing the result of that as the left-hand side of the initializer of init with age. So you'll often see this convention of double brackets cat alloc and then calling the initializer on the result. And you very, very rarely actually override the alloc method. It just allocates heap memory. There's no particular reason for you in most situations to override that. Once the memory was allocated, you can then call the initializer on that. And now we're going to call a method. So Felix likes other cat, shadow is how we pass in parameters. If Felix likes the other cat, then whatever. And another thing I want to do is see if it's Shadow's birthday today. And so to get a date, to get today's date, I use a static method on the NSDate class. That's one of the built-in classes in the framework. And that returns an NSDate star, a pointer to NSDate. And then suppose I have a static method on a calendar class that's supposed to check whether the cat's birthday is today. The reason this is here is that this is the first time we have a method that takes two parameters. And it looks really horrible, right? You write calendar is birthday shadow on date today. Now this does read like English, and this is why it looks like that. But again, it's kind of unique, and I'm not aware of other languages that use this as the only way of invoking methods. Now you have named arguments in C#, for example, or in Python, but this is the only way to invoke a method with multiple arguments in Objective-C. And the method name is calendar is birthday on date. And the parameters are just pushed in the gaps.
That's small talk.
That's what?
Small talk.
That's small talk, yeah. And it reads like English, which is, again, the reason for this choice. And then if it is Shadow's birthday today, then we increment Shadow's age. And this is how we access a property. And we get all the benefits of accessing properties in that it really looks like a field, but behind that there is a getter and setter that are being invoked to increment the age. And then we ask Shadow to meow, because it's Shadow's birthday. OK, so we have objects. We can use them. We can declare methods and properties, all right. The last thing I want to mention here is memory management and a couple of useful classes that you can use. So in terms of memory management, all objects are allocated on the heap. Things like integers, booleans, and floats, value types, so to speak, can also be allocated on the stack. But whatever class you write, whatever goes in an interface implementation pair, that's going to be allocated on the heap. And the alloc method allocates heap memory for you. Someone has to reclaim that memory. Someone has to delete whatever you allocate. And so iOS uses reference counting for that. There was actually a version of Objective-C that had an automatic garbage collector. But iOS, from the onset, used reference counting. So every class derived from NSObject actually has 3 methods supported by it, which are release, retain, and retain count. And this is how you manage the reference count of an object. The object has to know when you create a new reference to it, and the object has to know when that reference is going out of scope. And this sucks. I mean, no one wants to send these retain and release messages whenever you create a new reference, whenever something goes out of scope. So as of iOS 4, we have ARC, automatic reference counting, which takes care of manual memory management. And the way it does that is basically by having the compiler inject these method calls for you. So instead of you having to tell the object, now there is a new reference, now there's no longer a new reference, the compiler does that for you. So the compiler inserts a retain message whenever you create a new pointer to an object, and the compiler inserts a release message whenever a reference goes out of scope, whenever a pointer goes out of scope. Now, when using reference counting, there is this little subtle problem of cycles when 2 objects reference each other, and there's no automatic way for ARC to take care of that. So this is a situation when you use weak references, weak pointers, but we're not going to get into that in this talk. In most situations, 95, maybe 98% of your code doesn't have to deal with memory management explicitly. Only in these rare situations when you have cycles, you have to think about having one of the sides be a weak pointer, a weak reference. And this is the only form of memory management that you have in iOS applications today. There is no garbage collector other than that. There is no background process that runs occasionally at non-deterministic times and inserts pauses into your application. There's no such thing. Objects are released and destroyed when the reference count reaches 0 and the compiler takes care of the details. It sounds better than it really is, but it's almost like it's almost as good as I'm describing it. Now, some useful classes that we might have to use today, some very basic things really, like collections, come from the foundation framework, which is where NSObject lives, for example. The foundation framework has a class for strings. Strings are not just pointers to characters. Strings are objects that have a bunch of useful methods. And the class for string is called NSString. There's also a class for mutable strings, which you can change, which you can modify, called NSMutableString. We'll see, I think, both in the demo. So strings can be immutable or mutable. And to create a string, you have a special literal syntax using the @ sign. So if you have just a bunch of characters, you can create an NSString without calling alloc and init by just using this @ sign syntax. There's a similar thing going on for arrays. Arrays, again, are objects. They live on the heap. They have a bunch of useful methods. And you can put anything that derives from NSObject in an array. And again, you have a special syntax for declaring arrays without creating and allocating objects explicitly using the @ sign and then square brackets syntax. So this thing here will actually create an array object on the heap and insert A, B, and C into that array. And for dictionaries or maps, for key value pair collections, we have the NSDictionary and NSMutableDictionary classes. And again, we have a special literal syntax for initializing dictionaries like this. @ sign, curly braces, A, :B means A is the key, B is the value. And you can separate using commas and add more objects to the dictionary at once. This is, by the way, something that was added in iOS 6. The array literal syntax was added, I believe, in iOS 4 or iOS 5. So they're really still improving the language to make it easier, for instance, to create dictionaries and arrays, which is something you probably do all the time in UI applications and in other situations as well. OK, so that was the Objective-C primer. And now we're ready to see our first iOS application and discuss the other moving parts. And to do that, I'm going to use Xcode. And instead of putting a bunch of screenshots in the slides, let me just show you Xcode on my machine. So this is the project we're going to be looking at later. For now, I'm going to create a new application in Xcode. And Xcode asks me to choose a template for my new project. And there's a bunch of templates that I can choose from. I have templates for iOS applications as well as for OS X applications. You use Xcode for both. In fact, you can even develop command line tools that don't use Objective-C in Xcode. But most code you will write in Xcode is going to be Objective-C. Under iOS application, I have a bunch of useful templates, of useful detailed templates. For instance, I have this master detail application, which is something you'd probably use on the iPad, where you have a bunch of screen real estate. The mail application on an iPad is an example of a master detail application when you have a list of messages on the left and the body of the message on the right. Another example here is a tabbed application. That's going to be an application with a bunch of tabs, like the Twitter client, for example. Utility application is something like the weather or stocks app that basically has one main page and another settings page that you switch between. And I'm going to use, for now, the single view application that has just one screen. It doesn't limit you in any way, however, from adding additional screens later. It's just going to create a single screen for now. So I'm going to settle for that. And now it asks me for a couple of details. Let me call this project Software Architect Demo. And it's prompting me for a class prefix, which is a prefix it's going to use for all the classes it generates for me. So for instance, if there's a class called app, it's going to call it HI app for me. The prefix thing is more of a convention for separating different products and different frameworks. I'm just going to skip that prefix for now. no prefix. And finally, what kind of device I want to run my app on, so I can choose here iPad, iPhone, or universal app, which has UI both for iPhone and iPad. We'll work with iPhone only for now. OK, now it just prompts me for the location where to put this app and creates the application for me. Now, on the left here, I already have a bunch of files. This is pretty typical. I mean, Visual Studio is also very good at creating a bunch of files for you when you use any template from the collection of templates it ships. And so here, I have a bunch of files generated by Xcode, and they don't have any special prefix in our case. We have the app delegate, which I'll mention later. We have our main view controller, which is where the logic for our main screen goes. We have the storyboard, which is where we design our user interface. And we have a couple of additional support folders here. Now, if I just go ahead and click this Run button here, it's going to build and run this application on a simulator. I don't have a physical device connected right now. And so it launches the simulator for the iPhone Retina 3.5-inch iOS 7 version. And this is the app. The resolution here is such that the iPhone actually is higher than my screen. But this is our app. It's an empty app. You see the carrier icon here. You see the time. You see the battery indicator. And yeah, so the app is running. It's not super useful, but it's running. And I can stop it from Xcode. And then a simulator goes to this pristine state where you have icons. And you can switch between screens. And this is it's really a phone. It looks like the phone. However, it's a simulator and not an emulator. And what I mean by that is that it's not really running the same code, the same instructions as the iPhone. It's not running an emulated version of the ARM processor. It's running on Intel. It's running x64 or x86 code. So it's really just sort of a port of iOS to Intel hardware, to the Intel processor architecture. So one effect of that is that your app will run and launch much, much faster in the simulator than it will on an actual device. And this is not the case with Android or Windows Phone, for example. On Android, the emulator is known for being super slow, and the graphics are really bad in the emulator. On iOS, it's the other way around. You'll find that your app is super fast in the emulator, and you might end up shipping something that's really slow on physical devices. So take that into account. OK, so let's just review the files that our application consists of at this step. So the first thing I've mentioned is this application delegate, the couple of the app delegate files, an H and M pair. This is kind of similar to the application class in WinForms, or to the app class in XAML-based application. It's like a global entry point into your application. It has a bunch of methods that you can customize to determine what happens when the app is launched, when it's terminated, when it's suspended in the background, all kinds of things like that. And we're not going to insert any additional code into the app delegate at this time. The second thing is the view controller, the view controller H and M files. And the view controller is sort of the code behind for our main application's screen, for our main application's UI. And we're going to put some code in there, of course, because we need to manipulate that UI. The storyboard file is where you design the UI. This is like the XAML file. This is where you put the actual buttons, other components. This is where you define navigation between screens. And there's some additional support files, like icons, like localizable strings, which you can translate to different languages, a property list, which is kind of like a settings file. This is basically the structure of our first iOS application. So let's take a look at the MVC fundamentals and then start customizing our app. The view in MVC on iOS is a very passive component. It draws itself on the screen. It's totally generic. It's not customized for your particular application. So a button, for example, is a very, very generic thing. And the view does not contain any additional code that you provide. This is not where you do your custom appearance. This is not where you bind to data. The view is really just the thing that draws itself on the screen. The view controller, the controller of MVC, is where your logic is. This is what binds the data to your view. This is what reacts to events that the view might raise when something happens, like the user clicks a button or the user navigates through your application, moves their finger on the screen, whatever. And finally, the model in MVC is a bunch of UI agnostic classes which don't have anything to do with the view. They don't manipulate the view. And so a model in an MVC application could be a web service, could be a file, could be a database. By the way, iOS ships with a database engine called SQLite, which is also something you use on Android today. And so this is the fundamental MVC pattern. The thing to watch out for here, which is kind of different from XAML, is that the view is really super passive. You can't have binding in your view. You don't have dependency properties that you interact with in your view. The view is super static and generic. And the view controller is what manipulates and customizes the view. So before we talk about outlets and actions, let me go back to Xcode and open our storyboard, which is where the UI design is going to be taking place. And what you see now is the storyboard of our application. This is the main application screen. This arrow here on the left means it's the main screen. This is where the user is going to get when they launch our application. All very visual, of course. And this is the canvas. This is the design canvas that you can start customizing. For instance, let me go over to the library down here and pick something like maybe a button. And I'm going to drag a button and put it right here. A button. Delightful. And then maybe I'm going to put a segmented control right on top of that button. This is this thing that has a couple of segments and a selected one, similar to a radio button. And finally, maybe I want to have a label just about here. And that label's just a piece of static text. And of course, you can customize any of these things. So if I click that label, on the left here, I have a bunch of so-called inspectors. This inspector is the attribute inspector, and this is kind of similar to setting properties on a view in a XAML or Windows Forms application. For example, this is where you customize the label text. So this is a label. And this is where you customize the color and the font. And sure enough, it changes our label. However, it does not change its size. So let me just make this a bit bigger. You see that there are these nice guides telling me where exactly the Apple-defined margins should begin and end, and when this thing is centered or not. And let me just center the text in that label as well. So this is how you build the UI, and again, this is very, very passive. It's only going to do whatever you define in the attribute inspector. So we're going to talk about connecting this thing to our code in a moment, but first let me just run it. Okay, so here's our app in the simulator. It launched really quickly, and it's not going to be like that on an actual device, even though the app is kind of small. And I can click the button. I can switch between the segments in the segmented control. So it's all sort of working here. And let me stop the app. Now, to connect this thing to our code, to our view controller, which is supposed to manipulate the UI, we need two new concepts. And again, Apple have unique names for everything. And the unique concept here, the first one is called outlets, and the other actions. An outlet is a way for the controller to manipulate the view. So if the view controller has to change the text, or to change the enable, disable state of a button, or to figure out which segment of the segmented control is currently selected, you need an outlet for each of these views. So you create an outlet for every view that you intend to manipulate from your controller. And if you need your controller to respond to events, the other side of this communication, then you create an action. And an action is a method that is invoked when an interesting event happens in the view. And the view calls this method on the view controller. Now, in terms of actual code, actions are just methods, and outlets are just properties, but they have some tiny bit of special syntax that only Xcode will recognize. An action is a method that returns void, But instead of saying void, you use the IBAction macro. And IBAction is just a macro that says void. But when Xcode sees IBAction, it knows, oh, this is an action that I can now bind to the view. Wonderful. This is the convention. And an outlet is just a property of some type, like maybe UI text field, which is a text field where the user can put in some input using the keyboard. And it's decorated with this special IBOutlet macro. And IBOutlet is just a macro for nothing. It's just an empty space. But when Xcode sees IBOutlet, it knows, oh, this property is something I can bind a view to. So you put these outlets and actions in your view controller. And your view controller itself derives from a class provided by the UIKit framework called UI view controller. All view controllers inherit from UI view controllers. OK, so let's try connecting our UI to code. I have this segmented control. I have a button. I have a label. I want, for starters, I want outlets for all three. And I want an action for clicking the button. And by the way, let's call the button get weather. And let's change the button. Let's make the button a bit bigger. And let's change the segmented control to specify the city. So suppose we'll have 3 segments. Segment 0 is going to be London. The second segment is going to be Tel Aviv. And the third segment may be New York. OK, so we now have 3 segments. And again, I have to stretch this thing to fit. OK, and I want to keep it centered just like that. I think it's centered now? Yes. OK. So this is a wrap, and I need outlets for these 3 guys. OK, so this is going to be really surprising. I can't just double-click any of these things and expect something interesting to happen, because, again, it's Apple. So, for instance, if you double-click the button, it just makes the text editable. So to create an outlet, you need this weird feature of Xcode called the assistant editor. And this is how it works. First, let me just move these things away. You see these 3 buttons here. This is the standard editor, and this is the assistant editor. It has this nice bow tie. It's like a butler or something, an assistant, anyway. So you click the assistant editor, and then it opens side by side your view and the view controller behind it. Now, the view controller has some code I'm not going to need right now, so I'm just going to delete it all. And now I want to create my outlets. So watch this. I click the button, or maybe the segmented control, and then I Alt-drag. Sorry, I Control-drag. No, I Alt-drag. Come on. Alt. Man. Yeah, I Control-drag. Sorry, I'm all mixed up. I Control-drag from that beautiful segmented control to the interface section of my view controller. This is where the property is going to go. And so as soon as I release, it tells me, OK, I see. You want to create an outlet. That's fine. What do you want to call it? Let's call it city. And the type of that thing is going to be UI segmented control. I click connect, and it generates the property for me. It's of type UI segmented control star, and it's marked with this magic IBOutlet macro. And you'll notice there's this little gray circle here, which means this outlet is already bound to the view. And if I hover over that, it highlights the segmented control. So this is the UI experience here for telling what exactly the outlet is bound to. I'm going to repeat the same thing with the label. This is the weather info, let's say. And for the button, I'm actually going to skip. I'm not going to create an outlet for the button because I want to respond to events that this button will generate. So I actually need an action to respond to events. And so again, I'm going to Control-drag from that button down here to the implementation. And now Xcode knows I'm meaning to create an action because I can't put properties in my implementation section. So the action has a name, which I'm going to call getWeather. But the other interesting thing is the event. What event should generate this action? And so I have a choice here of quite a few generic events provided by the button. I have things like touch down, touch drag, drag inside, drag outside. The thing we're going to use is called touch up inside, which means the user has touched that button and then lifted their finger while still on the button. And this is how you click things, generally, on a touch screen. You put your finger down, and you lift it up while still focused on that UI control. You also have touch up outside, for example, where you would tap the button, but then move your finger and lift it up while outside the button. So this is how you choose the event to respond to. I'm going to go with touch up inside, and it creates the outlet for me. Get weather, it returns void, but Xcode thinks it returns IB action. And now let's implement this thing. I'm not going to access any internet-facing services because I've just tried it in my hotel room and it took a while to access the Wi-Fi, so we're just going to use pre-configured weather information. So first, I'm going to ask that segmented control which segment is currently selected. And that's the selected segment index property. And I'm going to do a switch over that. So if it's 0, then we need the weather for London. That's going to be easy. Weather info.text equals rain, break. Case 1, this is Tel Aviv, so hot. And case 2, this is New York, so fog. And here we have our first reactive application that takes input from a button and a segmented control and displays output using a label, a static label on the screen. Let me try and run this thing in the simulator. Let me choose Tel Aviv. It's hot. Fog in New York. Rain in London. Delightful. So this is how you create a UI that is connected to a view controller. You use outlets and actions. An outlet is how the view controller accesses the view. An action is how the view passes events to the view controller. OK, I think it was pretty easy so far, right? So let's take it a little to the next level by talking about navigation between screens. And in most application frameworks for mobile, this is pretty difficult. I mean, on Android, I don't know if you've done any mobile Android development, but you have this concept of activities and intents. And when an activity wants to transition to another activity, it has to create an intent and pass that to someone, and they take data back in the form of another intent. It's really all very complicated. And on Windows Phone, similarly, transitions between pages are kind of difficult, and you have to use URIs or types, and it's weird. On iOS, you design your whole navigation experience in the storyboard, and you specify the transitions visually. And this is, well, for me, this is one of the greatest things about storyboards. And I mean, Objective-C is kind of ugly, and outlets and actions take a while to get used to. But what I'm going to show you now for navigation is going to be pretty seamless. So I'm going to use a couple of navigation transitions. Let's take a look at two that are super common in iOS apps, and these would be the tab and navigation types. So the tab navigation paradigm is basically what the Twitter client uses, where you have a bunch of tabs at the bottom of the screen. And when you click a tab, it takes you to a different view. Now, the navigation controller navigation paradigm is where you have a bunch of views that are pushed and popped like a navigation stack. For instance, if you look at this screenshot on the right, I'm now looking at a tweet, and I can go back by clicking this back button on the navigation bar. So switching between screens using the navigation bar is the other kind of navigation you have in iOS. The way you switch between views and the way you specify the connection between your views is using the storyboard. So you could have multiple screens on your storyboard, which is exactly what we're going to do right now. And you connect these screens visually using arrows like these ones. And these transitions, these connections, are called segues. So again, there's a couple of new weird terms here, the storyboard and segues, but this is how you move from one screen to another. And it's all specified visually. There's a bunch of segue types that I'm not going to look at in this talk. The ones I'm going to use are probably the push segue, which is what the navigation controller uses. This is how you put things on that navigation stack. But the other kinds, for example, the modal segue, is how you pop up a dialog that covers the screen, and the only way to go back is by closing that dialog. This is the modal navigation kind. You also have, for instance, the unwind segue, which is what you use to unwind navigation, to go back. And you don't have to go back to the last screen. You can go back a few screens. This is why it's called unwind. So there's a bunch of transitions that you can use, and this is a partial list. There's also something called custom segue, which is how you specify a transition that's totally up to you, and you define which screen to go to. But I've seen only a handful of applications that really need any custom navigation like that. You almost always can use one of the existing segues for your needs. So before we discuss passing parameters, let me take a look at that in Xcode. So this is my storyboard. Let me just make this thing a little shorter and open the library. I want to add another view controller here. Recall, I started with a single view application. And so, yeah, well, I have a single view, and I have a single view controller behind it. But now we want to add another, and we have to use some navigation paradigm. So for instance, I want to use the navigation controller. Now, I can change my mind at any time by just clicking this screen, this view, and selecting Editor, Embed in, Navigation Controller. And this will create the infrastructure for me that then supports navigation by pushing and popping views. So if I do that, it has added a root navigation controller screen, which does absolutely nothing. This is not something that you can modify. And it is linked by this transition here to my original view. And now my original view looks kind of ugly because it is partially obscured by the navigation bar. So I'm probably going to move these guys down a bit. Say down here. Now in the navigation bar, which was provided by the navigation controller, I can now put some text maybe to set a title. So the title for this is going to be Weather App. And now I want an additional screen. So what I'm going to do is, in the library on the left, on the right, select a view controller, just a blank view controller, drag it to my storyboard, remove this thing from view. It's really kind of hard with the resolution here, but we'll manage. And then move this here. By the way, I can zoom out, but then I can't change any properties. This just lets me visualize my application, but if I want to edit anything, I have to zoom back in again. That's Xcode. Anyway, I now have these two navigation controllers. I have, sorry, these two views and two view controllers behind them, and I want to connect them in some way. Like maybe I want the button here to transition to this view, or I want an additional new button that will take me to that view. So let me go to the library again and choose a bar button item. This is what you can put on the navigation bar. And again, I suppose that if you have an iPhone, you've seen navigation style applications that have additional buttons or icons on their navigation bar. So let me call this thing show map. And so when this button is clicked, I would like to show a map of the selected location. And now I want to specify, let me again hide the library, I want to specify the relationship between the button and this view controller. And again, you do this very easily by control dragging. I select this thing here, and I control drag over to the other view. First time I saw this, I was amazed. Anyway, when you release, it asks you what kind of segue you'd like to use for this transition. A push segue would then embed this view in the same navigation hierarchy. So you could then go back to the original view, and this would be provided by default. And I can also choose other kinds of segues here. But let me go with push for now. And you'll see two things, really. First, there's this little arrow here, which is the segue itself. And in my view, I have a navigation bar. And let me put map up here. So we have two views connected by a segue. And let me run this to show you what the navigation experience is going to look like. So this is the top part of our view. There's no room for the rest. But if I click Show Map, it takes me to the secondary view controller. And there was also a nice built-in animation in there. And if I click this Weather App Back button, it takes me back. And by the way, the text here is, of course, taken from the title of the previous view. And I can also customize the animation. If I click the segue itself and open the inspectors here, I have, I think, somewhere in here, I don't really remember where, but there is a way to customize the transition. Oh, maybe only if I use the, yeah. If I use a modal transition, and I just want to show you this to give you an idea of the animation richness that we have. If I use a modal segue instead of the push, I can have a couple of transitions to choose from. For instance, let's go with flip horizontal. That's going to be pretty. Flip. I can't go back now, however. If I change this to cover vertical, it's going to do something like that. And finally, there's also partial curl here. And to demonstrate that, let me change the background color here to orange. Wow, this is a horrible color there. Okay, if I click this, this is partial curl. All provided out of the box. This is not part of the app. All provided out of the box. And if I click this curled page, it takes me back. This is a nice finishing touch. So in this case, there's no need to provide a back button. You just click and go back. Anyway, like I said, we want a map to be displayed here. So I'm going to take the background back to default. And I'm going to take that segue back to be a push segue. And I'm going to give that segue an identifier, which we'll need in a moment. And I'm going to call it show map. And finally, this says map, so we're done for now. OK, let's just test this thing real quick to see that it still works. I click this thing, takes me to the map, and I can go back. However, the background is now black, because that's really the default. Let me just make the background here white. White color. That's better. OK, is it white now? Yes. OK. So now I actually want to show a map on that other screen, which will require using a map view, which is provided by the MapKit framework, which we're going to use. It's provided by Apple, but it's not on by default in our project. And there's another nasty detail to take care of, which is passing the information from this segmented control over to the second view. And to do that, you have to give your segues IDs, which is what I've already done, and then you can customize what happens during the segue transition. And this is done using the prepare for segue sender method. This is the actual name, yes? Prepare for segue, colon, sender, colon. This is the full message, the full method name. And in prepare for segue sender, you get two parameters. One is the segue itself, which is of type UI storyboard segue star. And the other is whatever view that initiated this transition. In our case, the sender is going to be that button up there. And the sender for the same segue could be different in different situations. You could have multiple views performing the same segue and switching to another view. In our case, there's only going to be one sender. And actually, there's only going to be one segue, but we're going to be careful and check exactly what segue it is. Once we know what segue it is, we can take the destination view controller for that segue and pass information to it directly by setting properties and calling messages. So basically, you get an instance of that second view controller to which you're transitioning, and it's your class, so you can do whatever you want. Let's go ahead and do that. I know already that the weather app, the main view, has a view controller created for me by Xcode. This is this view controller, which we have been customizing all along. This is where we have the outlets and the get weather action. But we haven't yet defined a view controller for that secondary screen, for that second view. And we have to do that manually. So I'm just going to go here and say file new file. And the kind of file I need is an Objective-C class. And I'm going to call that map view controller. And it's going to inherit from UI view controller, just like the main one. And if I click through the wizard, I now have an additional pair of H and M files, which are the new view controller. It also has a bunch of code that I'm not going to need. I'm going to remove this for now. So it's an empty, clean, pretty view controller. And unfortunately, it's not yet associated with the view. I've just created a couple of files. I haven't told Xcode what I'm supposed to use them for. So I have to go back to my storyboard, hide this thing here, go over to my second view controller, open the inspector right here, choose the identity inspector, which is this guy. This is the identity inspector. And say the class, the view controller class for that view is the map view controller, which I've just created. I really don't know why there still isn't a wizard for this. This is Xcode version 5, the latest version of Xcode. And there still isn't a wizard that generates these files and connects them to the view. So this is why I'm showing this in such detail. We now have that view controller associated with the view. And now I want that secondary view controller to accept data. So I'm just going to create a property here, non-atomic, and a string city. And I'm going to pass the city in from the original, from the main view controller when the segue is performed. So I'm going to switch to the original view controller now and add that method. Right here, I'm going to add prepare for segue sender. Of course, everything is auto-completed for me. And this is how you line things up when you write Objective-C methods. You line up the columns together. So this is good style for Objective-C code. And so if the segue identifier is equal to string show map, and show map is what I specified in the inspector in the storyboard, then I know which segue it is. And then I know that the other view controller is really a map view controller. And I can cast the destination view controller for the segue to map view controller star. But the compiler complains because it doesn't know what map view controller star means, because I have to import the header file for map view controller. This is very C, C++ style. You have to import header files. Now that it knows what map view controller means, I can go ahead and say mapvc.city equals, and then, well, basically, I can either retrieve the selected segment text, or I can do this switch thing here, but I don't need to. I'm just going to ask the city segmented control for its well, I'm pretty sure there is a property that gives me the text, but I'm just going to make it quick and dirty here. So case 0, map VC city equals London. And yeah, I know, it doesn't make sense, but I just don't remember the property right now. In the second case, it's Tel Aviv. And in the third case, it's going to be New York. So this is how you pass information to the secondary view controller. You just take the object and you start manipulating it by calling methods, setting properties, whatever. It has been already created, but it's not yet displayed at this point. We're still preparing for the segue from the first to the second view controllers. In the second view controller now, I'm going to implement a method called viewDidAppear animated. And this method is called when that view is going to be shown up on screen. And so here, the segue has already ended. And so I'm sure that the city property is already set by the origin, by the original view controller. We still don't have a map up on the screen. So let's put a map, but this is where we're going to manipulate the map. OK, so to use a map, I'm going to switch over to the storyboard again, go to my secondary view controller, and open the library. And from the library, I'm going to choose a map view. Map view displays maps and provide an embeddable interface, blah, blah, blah. So let me just drag this thing over here. This is the map view. And I pretty much want it to fill the whole screen, including the area that's currently behind the navigation bar. And this is the new iOS 7 navigation bar design style. You're supposed to put content behind it if the content is scrollable. OK, so there's the map view, delightful. And if I try to compile and run now, it's going to fail. When I go to that map, I get an exception and get back to Xcode, and it's yelling at me. And the reason for that is that this map control isn't in fact part of the default set of libraries that your iOS application is linked with. You need to tell Xcode to include that library. And this is much easier in Xcode 5 than it used to be. In Xcode 5, you go back to your project, and then you have capabilities up here, and you can choose which libraries you're intending to use in your application. If you mean to integrate with iCloud, there's a bunch of settings for that. If you mean to integrate with Passbook, is anybody using Passbook? I'm using Passbook. Anyway, you can integrate with that. And for maps, if I expand this thing, it says, OK, with MapKit you can do so and so and so. And by turning on maps, you will link this MapKit framework to your project. And so to do that, I just have to hide everything else to make it fit on the screen. You just turn on that toggle button. And now it's linked, and everything is supposed to work. If I run this app now and click Show Map, it's actually showing a map. It's centered on the United States because, of course, the United States is the center of the world for Apple. And Apple is somewhere around here. And I can navigate that map and get to London and zoom in. And of course, there's a bunch of properties on the map view that will specify if I want to use satellite view, if I want to display traffic, track the user's location, and so on and so forth. But all we have time for is just basically centering the map around the city selected by the user. And I hope you'll forgive me if I just handle one city, London, and leave Tel Aviv and New York as an implementation detail for later. And by the way, you can see the navigation bar. It's partially transparent, so you can still see the map behind that navigation bar. This is the iOS 7 design style. OK, so going back to our map view controller.m, I need an outlet to manipulate the map view. So I'm going to open the assistant editor, and it doesn't do what I expected. So I'm going back to the storyboard, selecting that map view controller, and then switching to the assistant editor. And now I can drag. Oh, that's the wrong view controller. What's wrong with my assistant editor? Automatic map view controller.m. Thank you. So I'm going to drag from the map view, control drag, and create an outlet of type mk map view. And I'm going to call it map. And here it is. Xcode immediately complains it doesn't know what mk map view mean. means, and so there's this error right here, I have to import mapkit.h for that. And now it's satisfied, and we can manipulate the map. Now, I never remember this code by heart, so I'm just going to copy it out of the demo project, which I'll be giving you after the talk. Let me switch to that other Xcode window. And so here I also have a map view controller, and I have a bunch of code that's already pre-selected, as you can see, which sets the map center. Okay, so switching back to that other Xcode instance, inside manipulate the map, I'm going to say if self.city is equal to string London, then I'm going to set this to wherever London is. Does anyone happen to remember the coordinates? The longitude is easy, it's around 0, but what's the latitude? Let's try 33, no, maybe more like 50, right? Well, if we end up somewhere around London, maybe in the UK, it will do. And then I'm using a method on the map view called setRegionAnimated, which will center the map on that region and perform a nice animated flyover to that location. So it's going to be pretty beautiful. And to perform that transition, we use mk coordinate region make with distance, which is a global function, because it's not part of the upper layer of Cocoa Touch. It's part of the lower layer frameworks, which are C-style. So this is an example of a C-style API. They can get pretty ugly. So the center is the center, and the coordinate span is how many meters around that location we want. So let's go for 30 kilometers. Okay. Running the thing again, going to show map, and there's the beautiful flyover. And if we didn't end up in the middle of the ocean, I'm going to be pretty happy. Yeah, so it's now trying to pull the tiles over the internet connection. Let me increase the radius here to 300 kilometers. Probably ended up in the ocean. Interesting. Let's just try this one more time with 1,000 kilometers. Yeah, okay. Well, it's pretty close, right? I think the I suppose the center is somewhere here in the channel, but anyway, it's pretty close. So, yeah, so we have the map, and now that it's all cached, I hope the transition now is going to be a little prettier. Yeah, so that flyover is the result of using that animated method on the map view. Okay, so we've seen how to perform navigation between two different view controllers and how to pass data by using this prepare for segue sender method in the original view controller. Okay, so before we get to questions, let me just wrap this up a bit. I think that iOS development is really just a matter of learning another language, another framework, and another development environment. So it's just like anything else that you already know. If you're familiar with XAML development, you'll see some things are easier, some things are missing, like binding, dependency properties, converters. But you'll still manage. If you're familiar with MFC or WinForms or Qt, you'll find yourself at home with the general concepts of views, view controllers, transitions between views. So it's really mostly a matter of mastering the language, getting used to the framework classes, understanding how to structure applications, and performing navigation transitions. And there's a bunch of additional details, obviously. This was just an hour's worth of talking, like how do you work with data from iOS apps? What about networking, HTTP or otherwise? How do you put lists of data on the screen using what's called table views? How do you style the application so that it's a bit more interesting than just this blue on white design? But it's really all just details, I think. And so if you've been waiting for an initial trigger to get into iOS development, I really hope that you'll now consider doing something with that trigger and developing your own iOS applications. All you need is a Mac, Xcode is free, Objective-C is free, and the iOS simulator is also free. And if you want to test your app on an actual device, this is when you have to shell out the $99 a year to Apple. But up to that point, you only really need a Mac. Anyway, if you have any questions, we have, I think, about 10 minutes for questions, and so this would be a good time. And I also hope that you've enjoyed the conference, and thank you very much for coming, and thanks to the organizers for having me here. Thank you. So questions. I'm going to repeat them for the camera. Any questions?
Well, yeah, I got a question. You just said something about transferring the application from your Mac to your phone.
Yes.
You need to pay the $99 to Apple.
Yeah.
Is it also if you only want to have it in your own phone?
Okay, so the question is, what's all this business about paying Apple to put my app on my own phone? So yes, to install third-party applications on your phone without putting them in the App Store, you have to link your phone with the development certificate, a development provisioning profile, whatever, and to do that, you need to pay Apple $99. On the other hand, to put an app in the App Store, you also need to pay Apple the $99. So one way or another, if you want to run your own code on your device or someone else's device, you need to pay Apple for a developer account. It's $99 a year. It gives you access to internal documentation, to training videos, and it lets you put your app on devices. It's pretty much unlimited number of devices, but you have to install the provisioning profile on each device. For enterprise enrollments, there's also a program by Apple that lets you install a certificate on a bunch of enterprise devices and then install your app only inside your organization without going through the store. So that's the basic story. By the way, the Android story there is much better because you only pay $25. You only pay $25 once, and you can install your app on any device without going through the store. But, I mean, it's Apple. They want control over the ecosystem. It's understandable, I hope. OK. Well, if you have any additional questions, you can just come up to the podium. And thank you very much again for coming. Enjoy the rest of your week. Thank you.